All right. Hi, everyone. Good morning. And let's start. So, today's session will be load testing serverless application and understanding how Lambda scales. So, a quick intro about me. I work here at Serverless Guru as a senior serverless developer. And I started using serverless since 2000, around like 2017. And since then, I've been working on like multiple serverless applications in different domains, including ETT, e-commerce, IoT, and everything. And I also occasionally write blogs related to serverless at my personal blog, which is vishnuprasad.blog. And I also write it dev.to at the below address. And quick intro about Serverless Guru as well. So at Serverless Guru, we help companies to innovate. Companies innovate faster, reduce operational overhead, and streamline application development by leveraging serverless technologies. Also, by leveraging Serverless Guru, companies will lay a strong foundation with serverless and realize its benefits in the straight away. So on today's session, we'll be covering two topics. So the main topic will be we try to understand how AWS Lambda scales under different loads. Along with that, we will try to learn the basics of load testing, and we will have a quick demo of how to do load testing for a simple serverless application. So let's start with the load testing first, then we'll go to the scaling part of AWS Lambda. So you guys might be heard about or know about what is the load testing, but we will just cover the basics first. So what is load testing? So load testing is a non-functional software testing process in which the performance of a software application is tested under specific expected load. That's a basic definition of a load testing. So suppose you have an application or new application feature, and you wanted to test that how it performs under different traffic or with the real world traffic, but you don't want to test it before it goes to production. You want to test it before it goes to production. So what we can do is we deploy all the new feature or the application into a lower environment, and you generate some huge amount of traffic against it and try to see how it performs. So by doing load testing, we also get to know some information about the application. For example, when you do it, you will get to know how fast the system is and how much load that system can handle, and what all condition the system will fail. And it also helps us to get some information about like to measure the response times of your API endpoints and CPU or memory utilization of your EC2 instances or Lambda functions or containers, and latency of each API endpoints under different user loads. So these are the things which you can understand about your application when you do a load testing. The next thing is, how do we do a load testing? So there are a lot of tools in the market which are like open source and paid tools are there. So where you can install it on your local machine or any other EC2 instances or any other cloud environment, and you can generate load from there against your application. So some of the most commonly used tools which I know are this three: JMeter, Locus, and Artillery.io. So all three of them has like um, uh, similar features. Also, some of them has some advanced features. Some of them has a nice GUI. Some of them has just command line tool. So these tools are good to generate uh, traffic against application, but there are some limits when you use it, which is, so when you run these tools in a local machine, for example, in your laptop or on EC2 instance or a PC, what happens, the maximum amount of traffic or the concurrent requests that you can generate using these tools are limited to the configuration of your machine. For example, if your laptop has like 8 gigs of RAM and 16 gigs of RAM and 8 cores or 4 cores CPU, the maximum amount of concurrent requests that you can generate from this from your laptop or PC is limited to maximum of like 1,000 concurrent or 2,000 or maximum 3,000. Beyond that, the application will crash because of the high CPU or RAM utilization. You can also run these tools inside containers or inside EC2 instance, but with a huge amount of RAM and CPU. But it will end up costing too much for you to generate this much of this amount of traffic. So how can we avoid that, spending much money on this kind of tools and infrastructure to generate load against your application? So the answer we found was a tool called Serverless Artillery. So let's see what is the main difference. So serverless artillery is a combination of serverless framework. You guys, everyone must be familiar with serverless framework, and it's a combination of serverless framework and artillery.io, which I showed on the previous slide. And it is serverless, which is great. And it runs on Lambda functions. You don't need any infrastructure like any EC2 machines or like huge workhorse machine to run this tool and generate the code. And so with simple configuration in a YAML file, you can generate like a massive amount of traffic against application. For example, you can simply generate like 10,000, 20,000, 30,000 concurrent requests to your application with the help of a single Lambda function. So let's see how it works. So the serverless artillery is a simple command line tool. There is no GUI or something like that. So you install it on your local machine or in your laptop with the simple command npm install serverless artillery. That's done. Your installation is done. Then you write a simple configuration file called script.yaml or whatever the name you prefer to. And you put some configuration details like how long this load test need to be run and how much traffic it need to be generated and everything. You mentioned that in the configuration file. Then you do some command to deploy. The commands you see here, which is similar to the serverless framework command. So when you do serverless SLS ART deploy, what it does is it just creates a Lambda function inside your AWS account, which that function is called load generator function. Once you generate that function, when you run the second command called serverless invoke with your configuration file, SLS ART invoke. So when you invoke that, this particular function will create hundreds or thousands of Lambda containers according to the need, according to how much traffic you need to generate against the target. So it will spin up as much containers of Lambdas or execution context of the container of the Lambda function and generate the traffic against your target. So this is how actually it works, the basic architecture of how it works. So with the help of a single Lambda function, you will be able to generate a huge amount of traffic against the application without spending much money on the huge workhorse machine or something like that, or expensive laptop or something. So let's do a quick demo of the serverless artillery. This will be very basic. I hope everyone can see my VS
Yep.
Code.
Yeah, looks good.
This right? Yeah. So this is a basic HTTP endpoint, which we created for the load testing. So it has a Lambda function, it has a API gateway, and it has a Lambda function. DynamoDB table. So when a user requests the request go to API gateway, it goes to Lambda, and this Lambda will fetch some data from the DynamoDB and returns back. So this is the endpoint that we are going to load test. So when you call it, it just responds with the message HTTP response saying that okay, serverless is amazing. So this is the configuration of our application, basic configuration, and here we have the code, and we have another folder called load test where we mention all the uh, load testing configuration for the serverless artillery. So this is very basic configuration, but you can do lot more than this. There are like a wide range of features you can specify here. So you can go to artillery documentation and use them here. So here we are going to use only the simple ones. So here we specify the target, which is the endpoint that I show you here, this one. And under the phases, we mentioned like some variables like duration, arrival rate, and ramp up to configuration. So the duration is where you specify how long this load testing should be run. So here we specify 60 seconds, it is in seconds. So this load testing will run for like 1 minute. And the arrival rate is something called on every second how many users will be generated or how many requests will be generated. And in the ramp up to, you mentioned maximum of how much traffic, how much requests you need to create. So during this 60-second period, this load test will try to generate 1,000 concurrent requests against this particular endpoint. And in the flow section, we specify the type of the API, which is a GET, and you will provide the path. Now let's invoke this. Let's trigger this load testing. So you run this command called slsart invoke and your stage and the region. When you run this, you will get some response from the Lambda saying that, okay, I started the load testing with the configuration that you provided in the configuration file. Now let's see what all details that you can fetch for this particular endpoint by doing this load test. So to understand that, to see the performance of that particular endpoint during the load test, I have created a CloudWatch dashboard. So which has some metrics I have put. So one is called API request, API gateway request. Another one is the 400 errors from APIs, 400 errors from API, and invocation, Lambda invocation count, Lambda concurrent execution count, and Lambda throttling metrics, and the duration metrics for this particular Lambda function. So you can add as many metrics that you needed for your application, and graphs here. So now let's see if we received any request here. Okay. So since we started the load testing, as you can see here, it started plotting some graphs, which means it has generated the load against the API endpoint. And here you can see the Lambda invocation count generated, and it has the concurrent execution count. There is no throttling happened, and the duration of that average duration of that calls, which is like almost 1 second. And interesting stuff we need to see here is this one. It usually shows the API gateway count, which is the request count. It might take some time. Let's wait for a minute. Let's find it. Yeah. So if you see here, the total amount of requests which this load test which we have created is, it created like 3,000 yeah, this is 3K, which is 3,000 concurrent requests. This is not per second, which is per minute. So let's see if you convert 4,560. Yeah, the maximum which this load test created was like 66 requests per second, which because we specified less amount of uh, less amount of arrival rate here. So if we specify like 1,000 or like something more than this, so you will see more requests coming here. So this is how we do basic load testing with serverless artillery and serverless artillery against serverless applications. See, basically, you can do load testing for any kind of uh, um, environment. For example, if it's a serverless or container-based storage instance, you can use this particular simple configuration here, and you can load test. So basically, you just need to put the endpoint details here, and it will do the magic. So that's the demo. That's it. And let's go to the next session. So now let's try to understand AWS Lambda scale. So when I started working with serverless in the beginning, I always thought like it's infinitely scalable. That's what AWS says. It's serverless. You don't have any service. You don't have to manage anything like OS or patching the OS or something like that. You just write your code, you push your code, you deploy it, and AWS will manage all the scaling for you, which is actually true. It does the scaling, but how much it can scale? That was the only like there was a question we had in mind since long time, because all the application which I worked previously was like less traffic, had less traffic. The maximum we had was like 100,000 requests per day, which is like less than 20 or 30 requests per second for a Lambda function to handle, just like peanuts for Lambda to handle. So Serverless Guru, we decided to test the scalability of Lambda functions. So we said, okay, let's try Lambda and to see if it can handle like 30,000 requests per second, not per minute, per second. How it will behave if we hit it with like that much amount of traffic. So to do that, we created a simple API endpoint, which is the same which I showed you in the demo. Simple HTTP endpoint, which fetches data from DynamoDB and return back to the user. So we created a configuration file using Serverless Artillery, and we put our endpoint here, and we set some rules saying that okay, this will run for 5 minutes, which is 300 seconds, and arrival rate will be 500. And it should so during this 5-minute period, this will try to ramp up to 10,000 concurrent requests. And let's see what happened. So this is the same CloudWatch dashboard we used, which I showed you in the previous demo. So there are like metrics for API gateways, Lambda functions, DynamoDB rates, and etc. etc. So when we ran this particular load test, so this generated around like 475 thousand requests per minute against the endpoint. This amount is 400. This amount is the aggregate of 1 minute, not so which means this is 475,000 by 60. It is around like 7,000 concurrent requests. So this load test generated around like 7,000 requests against the endpoint, and let's see what happens. It created around like 100K invocations maximum at a time. And if you see this particular graph, which is the concurrent execution graph, you can see that when it hit a particular number, it started to go in linear. The concurrency is not going more than 1,000 concurrent requests, which was like a bit weird when we looked at it for the first time. And if you look at the same time, when it hit the number 1,000, you can see this particular graph, the throttling graph of the Lambda function. You can see that the Lambda started throttling all the requests beyond the 1,000. So then we looked at the documentation, and we understood that, okay, this is because there is a limit called regional limit for a Lambda function, which is for every AWS account in a region for Lambda functions, there is a regional limit called regional concurrency limit. That is set to 1,000. So every region has a limit of 1,000. It is a soft limit, but it can be increased. So what happens with that limit? When you application get traffic, if the Lambda function invoked the concurrency of the Lambda function goes more than 1,000, anything beyond like 1,000 will be throttled. So if you receive like 2,000 requests at a time, only 1,000 can be served. All the 1,000 will be throttled. That's because of this regional limit. This can be increased. So we did a test with increasing, but before going to that, let's try to understand what is a Lambda concurrency. So a Lambda concurrency, your function's concurrency is the number of instances that serve requests at a given time, which means if you look at this graph, suppose you have a function and it takes 200 millisecond average or max to process a single request, which means if it can process a request in 200 milliseconds, that particular container can serve 5 requests in a second. So the throughput of the function will be 5, and the concurrency of that particular function will be 1. So if the same function receive like 6 requests or 8 requests, what happens? The first function will serve all the 5, and the 6th one will be sent to another container of the same function. So what Lambda does is, when a Lambda receives the first request, it creates the first container, and that will serve the first request. And while the first container is serving the initial request, if another request comes, it will create another container to serve them. So the upcoming request won't wait in a queue or something like that. So in that case, so the concurrency will be increased. So in this case, the throughput is 5. So if you receive 6 requests, the concurrent there will be 2 containers running, and the concurrency will go to 2. If you receive 15 requests in a second, the concurrency will go to 3. So that is Lambda concurrency. And let's see this graph with the previous test to understand a bit clearly. So suppose you have a function and which takes around like more than 1 second to finish a request, and this particular function got like 1,000 requests in a second. So the concurrency will go to 1,000, increase go to 1,000. So all the 1,000 requests will be served without an issue. But if you get a burst request to the particular function, for example, if you get like 4,000 requests, the thousand will only the first thousand of the 4,000 will be served, and the 3,000 will be throttled. So this will continue the same way because of this regional limit. Unless you increase the regional limit, or only 1,000 concurrent requests you can serve at a given time. So we came to know that there was like a regional concurrency limit. So we decided to increase that. So we created a service quota increase request to AWS saying that, okay, we are doing some load testing for our application. Our application will have like too much of traffic when it goes live. And so we need to test it. So to do that, we need to increase the regional limits. So we requested for like a 30,000 concurrent requests, regional concurrency limit, and they approved around like 20,000, which was enough for the testing phase. So what we did, we again created a new load testing configuration, and we ran it for like 15 minutes and set the arrival rate of like 2,000 requests per second, and I ramp up to setting up to 10,000. So we're expecting, okay, we have increased to 20,000 and everything will be served without any issue. 10,000 requests. If I receive like 10,000 concurrent requests, it will be served. And here's the result. And during this period of 15 minutes, 30 to 45, the maximum amount it generated was like 9,000 concurrent requests. It created 9,000 concurrent requests. If you see here, the concurrent execution tab, there is no more linear graph. It's started going up and up and up. It didn't stop, and it's because we have increased. And the maximum here was like the maximum it created was like 4,000 concurrent requests. But we found something interesting here. If you see the throttling graph, so when it hit a particular number called 3,000 here, Lambda started throttling some of the invocations or the requests. Not all of them, but some of them. At first, we didn't understand why. Then we looked at the Lambda scaling documentation and figured out that there is something called, there is another set of limit called burst concurrency limit. So let's try to understand what is the burst concurrency. So for an initial burst of traffic, your function's cumulative concurrency in a region can reach an initial level between 500 to 3,000 instances. So which means, and this limit can be vary per region. So for example, in US East 1, the burst concurrency limit is 3,000. And if it's in Mumbai, or it's 500. Let's try to understand how exactly that is. So let's take the same function, which takes one second to process one request, and it receives 1,000 requests. Everything was fine. Nothing got throttled, and you got 4,000 a burst of 4,000 requests. The first 3,000 is served, and the 1,000 is throttled. It is because of the burst limit. So in the US East one, the throttling burst limit is 3,000, which is the hard limit. You cannot increase it. Okay, so among the 4,000, 3,000 served, but 1,000 is throttled. But in the next minute, something happened. The next minute, the 3,500 is throttled. Not all the 4,000 is throttled. 3,500 is served, but only the 500 is sorted. It is because um, when you hit the burst concurrency limit, Lambda will scale slowly. It won't scale instantly. So on every minute, Lambda will add additional 500 instances of that particular Lambda or execution context uh, to the function. So in the first minute, at the initial level, the 3,000 served, 1,000 sorted. So in the next minute, it added 500 more. And the next minute, it added additional 500 more. So in the second minute, all the 4,000 is served without any issue. And the next third minute, we have 4,000 concurrent containers running. So it served everything without an issue. So this is how it scales. After the initial, after you hit the burst limit, Lambda will add additional 500 containers every 1 minute. So this is how Lambda scales with high traffic scenarios. So there are like different architectural patterns that you can implement to avoid to hit this limits. So you don't like run into throttling issues. So there could be something you could implement like retry mechanism at your client side, or put the request into a queue and control the concurrency. So there are like different architectural patterns, which will be a topic for another talk maybe. And yeah, so we ran two tests and we realized like there are like two type of limits, which has put by AWS. The first one was the regional limit. Then the second one was the burst limit. So at the same time we were doing this test, there was something called provision concurrency launched. So we tried to use that and see how Lambda performs if we put provision concurrency. So let's see what is provision concurrency. So provision concurrency initializes a requested number of execution environments so that they are prepared to respond to your functions invocations, which means you can specify a number of concurrent containers which need to be run for your function all time. So if you go to console, the Lambda console, and take your function and put a provision concurrency of 5,000, the Lambda function will always have 5,000 execution contexts upon running all the time, or until the time you disable it. Which means if you put 5,000 concurrent provision concurrency for your function and you receive like 4,000 burst request or invocation against your function, all the requests will be served without any throttling or any cold start. So if you have like 10,000 provision concurrency enabled on your function and you do 10,000 requests in a second, all will be served without any issue or any throttling. And so that is provision concurrency. So we tried to enable that, and we enabled like a provision concurrency of 10,000 to the particular function, and we ran the same load test against the application. And let's see what was the result. So during this time period of 15 minutes, it created around like 9,000 concurrent requests. And if you see this particular metrics, there's nothing is throttled, which means all the invocations were fine, or all the requests was served without any issue at the Lambda side. Whatever, so all the invocations are served without any throttling issues, which was great. And Another fact about provision concurrency is when you use provision concurrency, the Lambda billing is no more like on demand or pay per use. So when you enable provision concurrency, you need to pay for the time which is enabled. For example, if you enable this provision concurrency for 1 hour or 1 day or 30 days, you have to pay for the time that it is up and running. So it will be a bit expensive compared to the normal Lambda functions, but it does the task for you. And there is another way you don't have to provision all the time, but there's a feature on provision concurrency called auto scaling, which you can, using that, you can add more provision concurrency uh, with the help of like some CloudWatch tool. If you see this particular graph, the utilization graph, okay, so this utilization graph says I had enabled around like 10,000 provision concurrency. So the 97% of that concurrency was used. This is that graph mentioning that. So which means, so if you enable any if you create a matrix on this particular uh, uh, namespace, and you can apply some rule. So for example, you have some shell, and that could be a very busy function tomorrow, maybe because of some Black Friday sale or something, and you don't want to fail it. So you can set create a CloudWatch metric saying that, okay, if my provision concurrency utilization goes more than 50%, so you put like 100 provision concurrency on the function, and when you on the metric you say, sorry, on the CloudWatch alarm was metric you say, if it goes more than 50% of the utilization, add more containers to or add more provision concurrency to my function. So when it goes to more than 50%, you can specify a number like add 1,000 more or like 2,000 more provision concurrency to your function. So it will automatically add more provision concurrency, so your function can receive more requests without any issue. And once it goes beyond less than 50%, you can remove them automatically. So that's how provision concurrency works. So when you enable provision concurrency, you can get rid of cold starts, and you can avoid this kind of limits, the burst limits or something, or the region limit. So a quick recap. So we learned these things during this talk. So your function's concurrency is the number of instances that serve the request at the given time, and there's a regional limit. There's a regional limit called regional limit of like a default concurrency of 1,000, and there's another set of limit which has put by AWS, which is called burst concurrency limit, which varies per region, and we learned about what is provision concurrency is and how it works. So that's it from my side. And if you have any questions, I will try to answer.
Yeah, I guess one question, since I have a microphone, would be how important do you think it is for like companies to think about these type of limits ahead of time when working in the cloud and building serverless apps?
Oh, sorry, can you come again?
Yeah, like how important is going through a process of load testing serverless applications before production?
It's actually good to know, like you'll be able to know where things can break when you hit the real world traffic. Like you didn't know unless when you are in a developing phase, like you will be only using some dummy data to test your application or dummy traffic, less amount of traffic. But if you do load testing, you will, like I showed in the initial slides, you will be able to understand where the application can break and where the application will take more time to respond. All this kind of stuff you can learn before you go to production, and you can fix them before going to production and make it more scalable.
Awesome. And while we're waiting for more questions, feel free, anybody that's listening, to drop one in the QA section. When it comes to like a straightforward development workflow for doing this load testing, do you recommend using Serverless Artillery and then playing around with Lambda provision concurrency? Or is there like, if you were building an app right now and you wanted to scale, are there like a couple of like simple bullet points that you would want to hit and maybe skip over certain things like Lambda provision concurrency? Yeah, how do you think about that? Like what simply would you set up if you're trying to hit scale for Lambda?
Can you comment? I didn't get what exactly.
It's like super jumbled. No, so like I'm thinking through like, let's say that I have an application and like maybe there's certain things like maybe Lambda provision concurrency is, there's a way to maybe architect where you don't have to use provision concurrency. Are there situations like that? And if there are, is there like a, you know, if I'm like new to it, I want to load test, I want to understand where things are going to break down. What would you ever use provision concurrency, or how do you think about that?
I wouldn't use provision concurrency unless it's very important for it. It's so like there are like different architectural patterns that you can control the concurrency against your applications. I mean, I've seen talks regarding that. I'm not really always with that patterns, but there are like patterns you can control the concurrency by putting the request inside a queue, and you can avoid actually having provision concurrency to handle them.
Okay, and behind your application, it's not just the like in this demo we looked at like API Gateway Lambda, but there's also going to be databases in the background and things like that. How does that stuff play a role when you're thinking about scaling out a serverless app?
Yeah, that will also, like when you're building an application, actually the downstream, you will also need to actually think about the scalability of your downstreams as well. It's not the API gateway or the Lambda function who sits in front, right? So you need to think about that as well and find a way to overcome that. So yeah.
And with the kind of stuff that you set up with the CloudWatch dashboards and being able to see the metrics, if you had you know, like RDS behind it or DynamoDB behind it, would that just be like adding additional views into the dashboard and then measuring as the load test happens? You know, if that Lambda function is like putting stuff into the database or getting stuff out of the database, would you just be seeing what the transactions are happening there from the CloudWatch dashboard view? Would that kind of be the only addition you would have to make to test it?
Yeah, I mean, your application will have like different endpoints, right? So during the load test, maybe you can do different with the Artillery. I've seen like you can put multiple scenarios, so you can do different load testing against different parts of your application. So in the CloudWatch dashboard, or you don't have to use CloudWatch dashboard. You can use any dashboarding tools or monitoring tools like Grafana or Epsilon, Lumigo, whatever that you can use. So you can leverage the feature that they provide. So you can measure your application performance there as well.
Awesome. And it looks like we have a question that came in, if you're able to see that.
Oh, let me see.
Oh, you know what? If you don't have another screen, I can read it off. So it says, yes, it says, how has serverless changed since you started in 2017? And are the business use cases becoming more sophisticated? So how has it changed since 2017, and is the tooling, I guess, maturing and serverless maturing from your view?
Exactly, it is. Yeah, it is maturing day by day. So every year, Amazon, like AWS, comes with new features on top of existing features as well, and which makes our life easier. So yes, it is actually evolving in a very high pace.
Awesome. And there's one other part to this question. It says, how would I know serverless is the answer to my problems rather than doing something hybrid or more traditional?
That's kind of like I'm not. I don't know how to answer that actually.
Yeah, so I guess like yeah, maybe to rephrase it in a different way.
You could answer it better than me, man.
No. Okay, so let's see. So how do I know if serverless is the right answer to my problems? Okay, so yeah, so if you have like hybrid architecture or traditional or serverless, if you're approaching, let's say it this way, if you're going to approach a application development today in 2021, how would you go about it, Vishnu?
I prefer serverless because, like, if you're creating something new, a new application or something like that, serverless offer you the space, like the go to production time will be faster compared to other application model, something like containers or something like that. So serverless give you that kind of speed to create something from scratch to production level, like within 1 or 2 months from the POC space to the production phase. You can go in like maximum like in a period of like 1 or 2 months or maximum 3 months. So I would prefer to use serverless in that case.
Gotcha. All right. Well, are there any other questions? Yeah, I think earlier in the talk you mentioned where people could follow you. Vishnu, do you want to call that out one more time?
Yeah, you can follow me at like you can go to my blogs and you can follow me at like my Twitter or something like that, or LinkedIn. I don't have the addresses here.
Okay, awesome. All right. Well, yeah, I think if there's no more questions, then maybe we can wrap up early. Any final thoughts before we close out, Vishnu?
Oh no, all good.
Okay. All right. Well, thanks everyone for attending. I'll leave it to Vishnu to close us out with the closing out the webinar. Really appreciate everyone coming out and hearing the talk. And let us know on Twitter if you have any other questions that you want to see answered or you have any feedback around the format. Thanks again.
All right. Thanks. Bye.